All right, so we are getting into problems where you're going to often forget that there's two answers to them. All right, to begin with, I want you to think about, where is sign positive? It's not just one place, it's two places. And that means you're going to often have two answers to a question like this. Sine of some angle is equal to 1/2. I already know the answer. It's 30 degrees. I have that one memorized. And you should too, because it comes up a lot. Even came up on one of our tests. And if you knew it was 30 degrees and you also knew the radians for that, which was what, by the way? Pi/6. Then you already knew the answer. Boom, done. Okay. Well, if you had to do it the old-fashioned way, if you don't have it memorized, you'd need to know which quadrant you're in. But there's two quadrants where sine comes out positive. Do you get that in that whole all students take calc deal? All students take calc. That sine is positive both here and here. So there's two answers to this question. There's the answer that's kind of more normal one, and that's where sine of 30 degrees makes it equal to 1/2. I think that green line's going too far past the middle. Just fix that a little bit. That's closer to this now. Anyway, but there's also one where, there, I'll just cheat like that. There's also one where sine will be over here and it'll come out to be positive 1/2. All right, if I know the answer is 30 over here, anybody want to take a shot at what it's going to be over here? 1/50. Because then when it's 150, then this language is called the reference angle will be 30, and that's when it'll be 1/2 in this quadrant. Okay, so we got two answers, one in here, one in here. And the first answer was 30 degrees, and the second answer was 150. Notice you've got two answers to the question. All right, I want you to draw me a big circle like this, and I'd like you to divide it up into the 4 areas by making a big line like this, a big line like that, and I'm going to ask you to figure one out for me. Here, I'm not even going to show where it goes yet. I want you to figure one out. If I had tangent of theta equals -1, would you agree that I could put that over 1 and have it be the exact same thing? Except now, why is it better? Because it tells me two sides. Otherwise, kids will think I only gave it one side. If you put it over 1, now I've got two sides. Where is tangent negative? That's your first job. In paper or an iPad or whatever to write on. So you should be able to cross off 2 of your quadrants because tangent's only negative in 2 spots. If you do the all students take calc deal, A, S, T, C, you'll realize that tangent's only negative. We'll put it this way. Tangent is positive here, so it can't be here. Tangent's positive here, so it can't be here. So that leaves me 2 spots. All right. Now, how can I make tangent be this -1 over 1 thing? I'll just draw a triangle. You don't have to worry about whether it's a 45, 45, 90 or a 30, 60, 90. My advice is to make it kind of blah shaped, as in you don't want to make it super skinny or super fat. You just want to make it kind of an average shape, maybe like a 45-ish, because it's easier to draw in there. If you make yourself a really tiny triangle, it's really hard to like label the size and stuff. So make it kind of biggish. And then opposite over adjacent. Opposite -1, adjacent 1. Now, what is wrong with what I just did? Yes, sir. Okay. The opposite is this side right here. But what's wrong with how I label it? Yes? That's okay. Thanks for trying. I just labeled something wrong. Yes. Yes. This negative can't be there. That can't be negative. It's going up. That's a positive one. That's a negative one. So how come it's negative up here? Well, that negative could be anywhere. That negative could be here, or it could be here, or it could be here. Okay, so you have to pick where to put it based on looking at the picture, and only this one logically should be negative 1. It's going this way. All right? So I just know one of them is negative. All right, so now, if it's 1 and 1, then I hope you know that... Oh, what? Okay, hold on. Get back. All right, if it's... these two sides are 1. I hope you know this is square root of 2, right? And remember that the hypotenuses are always positive. The other numbers can be negative. The hypotenuses won't. These are the radius, and the radius needs to be positive. All right, so now I've got my triangle drawn. And now I can say to myself, there's only one triangle where it would be 1, 1, and root 2, and that would be 45, 45, 90. If you said 45, you would be completely wrong. Because two things. Number one, tangent of 45 degrees instead of that angle, if I put a 45 there, will not equal negative 1. Tangent of 45 will equal positive 1. You get what I'm saying? Try it on the calculator. Grab your calculator, please. Type in tangent of 45. You will find it is not negative 1. Tangent of 45 would be really where this would be if it was 45. That's going to be positive. Tangent of 45 is going to be positive, and I want it to be negative. So the answer isn't 45. Exactly. It must be this angle right here to bring me to here. And this is 135, so the answer is 135. And I'm still wrong. Because they're going to ask for the answer in radians. Yes. So then, after I change this to radians, I'm going to hopefully remember which one that is. Okay, so let's see. 45 is 1/4, so it'll be 2/4, so it'll be 3/4 pi, yep. And if you aren't good at that, you want to get good at that, you want to realize that it was like 45 plus another 45 plus another 45. So it's 3 sets of 45, and each 45 is pi over 4. So it's 3 pi over 4. Another way you can do it, if you don't like that way, just multiply it by pi over 180. But then the problem is you're going to have to reduce that, and it ends up being 3 pi over 4. Okay, and I finally get to that point, and I've caught 3 different things I could have screwed up on, and I'm still wrong. Because there's 2 answers. Remember how I did all that work in here, and I got my answer for in here? But isn't there also an answer in there? Yes, there is. Okay, this is where trig starts to get real. All right. So now if I have to find out where this would be, if this was a 45-degree angle, you can do something kind of cool. You can extend these lines out right here and use some geometry and say, oh, this and this are the same, so that's 45. But the answer isn't 45 down there. It's all the way around here, which would be 360 minus the 45, which would be 315. But then it's not 315 because you got to change it to radians. But I dotted my 1. That was weird. I dotted my 1 with a degree symbol. I think I've lost my mind. All right. 7 pi over 4. Almost 8 pi over 4, which would be there, which would be 2 pi, which would make sense. Right? All right. Whew. That's some tough stuff. Just look at the board. Yes. It is going to be like that. Yes. Always is such a big word. If you are in this situation where it's like this, and they're across from each other, straight across from each other like that, yes. But there'll be other ones where the 2 places where all students take calc, like for instance, if I say cosine is equal to positive 1/2, then I've got 2 places that work, here and here, and I can't just add 180 to it to make that. See what I mean? So if they're across from each other like they were before, then that was a great idea. But for this kind, it wouldn't work so well. All right. On that note, why don't you try figuring out this one? If cosine is positive 1/2, it's either here or here. Can't be here, can't be here. Draw me the triangles. Figure out the angle Remember to answer in radians, because these questions are pretty much always going to have this disclaimer at the beginning that says the answer should be in radians and should be positive. As in, you can't say, wait a minute, I could call this negative 90 degrees. Nope, don't do that. Now, I'll tell you though, if you just do one of them well, it's not that hard to do the other. Some of you are not actually right. Let's do it. Looking isn't good enough. You need to be right. Draw me a picture. I won't be able to even tell what you've drawn. You draw a picture of your mother on there. It'll look like you're right. Alright, so then if I go like this, and I'm not sure exactly how to draw the triangle, so you just kind of slap them up. And then I can go, cosine is adjacent over hypotenuse. Adjacent is 1, hypotenuse is 2. Now I'm starting to get closer, and then I can say, okay, it must be 1, 2, and the other must be root 3. And I can go, what do I really want here? I want how many degrees, because they gave me the sides. I want the angle. The angle for this one is not 30, because that would be like the one across from the 1. It must be a 30, 60, 90. This must be a 60. I've got it, 60. No, it's not 60. He said it's got to be radians. So then I got to go back and say, that's pi over 3. Yay, I've got it, but I don't have it yet, because I really need 2 answers. You get that? All right. So at 60 or pi over 3 is a good start, but then I need the other answer. The other answer would be just exactly like this, and it would be down here, where this is 60. And that would mean it's 300. But it's not 300. You have to be constantly changing over to radians. If you've been thinking radians, it's really much easier. Let me show you what I mean. If this is 1 pi over 3, this would be 2 pi over 3. Oops, but there. This would be 3 pi over 3, 4 pi over 3, 5 pi over 3. Cool, 5 pi over 3. 2 answers. That and that. Yes, sir. Good question. Negative answers, even though negative 1 pi over 3 is where we really are here, if you want to use negative. But you're not allowed to, because in the directions it'll say you can only give positive answers. All right. Now this only gets harder by including what we did yesterday, which shouldn't be new, but I know you just learned it yesterday, so you're not awesome at it yet. Remember these little formulas? Sine was y over what? R. And cosine was what? X over r. And tangent was what? Y over x. Excellent. You have an excellent medium-term memory then. All right, so you're going to use these again today in this context. What if you can't draw a triangle? And you're supposed to do the same kind of a problem. What if they say, instead of like saying tangent of theta is negative 1 over 1, what if they say tangent of theta is 0? You're going to draw me a triangle with the side at 0 over 1? No. Well, you could actually, but you got to use those imaginary triangles. So, what I'd recommend that you do is think this way. Can you put this over 1? Believe it or not, you can. 0 over 1 is still, just like any other number, you can put it over 1. Because 0 over 1 is still 0. And now I've told you 2 sides, right? All right, so now, here's the part where I would go, I know that tangent of theta is equal to y over x. So didn't they just tell me a y and an x? Do you get that that's really screaming out 1 comma 0? It gave me a y here and the x here. So where is 1 comma 0? It's right here. So where am I if tangent of theta is equal to 0? I am right there. And I can't draw a triangle for that because it's a quadrantal. And so what is the angle we're talking about? Right there. It's either 0 or 360, or you could say 2 pi. Is there another place? Yes, there's always 2 answers. So where's the other place? Where's the other place? How about if I try this? There's 4 spots it could be. And let's see which of them will actually work. Would you agree that this one's 0, negative 1? And this one's negative 1, 0? And this one's 0, 1? Which of them have the y equal to 0? Because we want this to equal 0, and it's y over x, so y needs to be 0. This one, this one. So the answers are 0 and pi. Alright, so problems today usually have 2 answers. How are you going to know that on the test? The beginning of the problem directions are your clue. The directions at the beginning say give all answers between 0 is less than theta is less than 2 pi. And notice that that does not include negatives if you think about that. So it's trying to tell you that the answers have to be between 0 and 2 pi. That's a clue that there's 2 of them. But kids often forget and they'll only have 1 or 2 answers. So I'll give you one more, and I want you to try this one on your own. This is one of your homework questions, so we'll see if it sticks. Tangent of theta is equal to negative root 3. First thing I'd do is put it over 1, because now I've got 2 sides. Figure out where you are. Cross off some quadrants. Find the right quadrant. Draw a triangle. Gentlemen, set that object aside. You do not need that black plastic thing with buttons. You won't be allowed to use it on this portion of the class. So you can think to yourself, which quadrant do I want? AS tiers. Got it narrowed down. Tangent positive here and here, so it can't be here and here. Once you find out one of your 2 answers, the other one will come quite easily. Slap the triangle. Tangent's opposite, adjacent, opposite. This is 3 adjacent to 1. I really should move the negative down to that one. That would make more sense. That's 2. Now I can tell which triangle I'm in. I'm in a 30, 60, 90. Depending on which angle is at 60. But why don't I use 60? Because it's negative and I need it to get over here, so it's not 60, it's the 120. Okay, it's 120 degrees. Now, that you can just change over to radians. Hopefully, if you can do 60 is like pi over 3, 120 would be like pi over 6. Raise your hand if you had pi over 6 as one of your answers. Oh. Good. I just did it wrong. I'm going to try it again. Pi over 3 was 120, or was 60. 60 degrees was pi over 3. And then I tried to double it, and something went terribly wrong. I'm trying to double that, and I get 2 pi over 3. There we go. How many of you had that is one of your answers? Okay, good. Phew. Now, if I draw my little geometry here, and somebody smart before had said, hey, can't we just say that that's adding 180 or adding a pi to it? Sure you can. But you got to have it in the same units. Okay, so that would be adding 3 pi over 3. So if you have 2 pi over 3 and you add 3 pi over 3, that'll work, because it'll end up with 5 pi over 3. And that'll be the right answer. Otherwise, you can just think this way. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. That's where I am, 5 pi over 3. All right. These are not easy. I know that. There's so many little places that you could stumble and fall. All right, let's, we'll start the worksheet together here. I'm going to pause for a second while I hand those out. Okay, I'm back on the recording, and we are doing problem number 1. Find the 6 trig functions of an angle whose terminal side passes through 5, negative 12. Picture. You need a picture. Once you see it, you're going to be like, ah, that's child's play. 5, negative 12. Over 5, down 12. So it's something like that. So there's my spot, 5 comma negative 12. And I have a line going through that. So then I obviously can make a triangle. Doot, doot. There we go. And I now know 2 sides of my triangle. I am doing problem number 1 for you. I recommend sketching number 1 with me because it'll make your life better later. All right. Utilize the pencil in front of you. This is x is 5. This is y is negative 12. And does anybody happen to have the triangle that has 5 and 12 memorized? 5, 12, what? 13. 13. And I can prove it to you. 25 plus 144 makes 169. Square root of 169, 13. Okay. So now I got my 3 sides. That's all relatively easy stuff. Now what am I supposed to do with it? Find the 6 trig functions of that. Well, what angle am I talking about? There's 3 angles. Only this one really matters. All right, so if I want the 6 trig functions of that, what are the 6 trig functions? Sine, cosine of it, tangent of it, and then all the flippin' sisters. Turn that into cosecant of theta, and secant of theta, and cotangent of theta. And those are the ones that will be just really easy. You'll just flip over your answers for the red ones. All right, so sine of it is just opposite of hypotenuse. Once you get the triangle drawn, this is super easy now. Opposite over hypotenuse. Opposites, negative 12. Hypotenuse is 13. Negative 12 over 13. Doesn't really matter where you put the negative, but it's got to be in there somewhere. And then you flip them. 13, negative 12. Again, it doesn't matter where the negative is. You want to put it on the top? Go ahead. All right, I think you can get it from there. Once you got the triangle drawn, easy. Okay, let's go to number 5. It's a question that I did not cover, and that's why one of the reasons I'm glad I start the worksheets with you. Let's talk about numero, is it cinco? All right. It is lunchtime. We'll talk about this after lunch. Oh. All right, so number 5. You need to know how to do this kind, where it says sine of pi over 6. And if they just said that, it's like saying pi, sine of 30. And do you have that one memorized yet? I told you it comes up a lot. What is it? It's a half. Done. Okay, but they added the problem in. Oh, and if you didn't know what it was, you'd have to go, okay, what's sine of 30? And if you didn't know what it was, you have to make a triangle. 30, 60, 90, 1, 2, square root of 3. And then you can figure out that it's opposite over hypotenuse is 1/2. All right, but the point of this problem is more about this. Plus, and it adds this ridiculous number of 49,000 pi. Well, if we simplify that down, do you get that that's like a whole bunch of sets of 2 pi? And what are they trying to get at? If you add 2 pi, do you get that it's the exact same place it was before? So basically, you can ignore when they say like add 2 pi, you can just ignore that. What if they say add 4 pi? Just ignore it. Because you're going around to the same spot you were at before. Again, if you're at pi over 6, you're right here. And then if you go around another 2 pi, you're going to end up right back on top of itself, same spot. So you can just ignore that. But what if they add an odd number of pi's? Then, if they add an odd number of pi's, like it boils down to if it was a 1 pi or 3 pi or 5 pi or 7 pi, then you're adding pi. Guys, listen. So if you're adding pi, that means you're moving from here. Let's get it down to be just the blue one now. If you were there and you add pi to it, do you get how you're going exactly across from it over here? Okay. So then you will have to get a different answer than you would have had. You know what I mean? It's not just the same exact answer. It's probably going to be the same ratio, but it might be negative instead of positive. All right, so the moral of the story is, if this thing they're adding is an even number of pi's, like 2 pi, 4 pi, 6 pi, then you just ignore that. And you act like it never happened. If it's and you can just cross it off like this. If it's an odd number of pi's, like 1 pi, 3 pi, 5 pi, then you actually have to add them together. And say this would be like 6 pi over 6 plus 1 pi over 6. That's like saying sine of 7 pi over 6. Now you can do the problem. You figure out where 7 pi over 6 is, and you do the problem from there. All right, it's going to be the same answer, but negative, I think. All right. Get that? Then look at number 5 again. Can we just cross off that 49,000 pi? Is it an even number of pi's? Yes, it is. So you can cross it off. All right. 49,000. Anything that ends in 1,000 is even. Okay. I know 49 is odd. I get what you're saying. But that's like saying 300 is an odd number. It's not. It's an even number. The 100th part makes it even. Okay, anyway, so I think you can figure out the other ones, whether they're odd or even numbers of pi's and whatever. Let's 8 through 22 on the worksheet is a little bit of overkill. I don't think you need quite that many. You may skip 17, 18, 19, 20, 21, and 22. 17 through 22 you may skip. All right. Now let's do one of those ones on the back side, which are the new kind for the day, the hard kind for today. Let's do number 23, please. It says cosine of theta equals a half. All right. My first thought is it told you that cosine is positive. Do you remember how we do this now? Everybody draw me a circle like this and put in a little ASTC. It's your new friend. You're going to do this for almost every problem on your test. You're going to draw one of these things. Draw one right now, please. Number 23, sir. Okay, next thing is you cross off the areas that won't work. Where's cosine positive? Here and here. So I cross off here and here. Okay? Now I know my triangles have to be in these two spots. Just start by making one. Okay? And it might be smart to make the other one right away just so you don't forget that it exists. Because otherwise you're going to get all done with the problem, get an answer, and forget there's 2 answers. So just for fun, I'm going to make the other triangle down there. All right? Now this one's got angle theta, and cosine is 1 over 2. Cosine's adjacent over hypotenuse. This is 1, and this is 2, and that makes this square root of 3. And then I just have to figure out, where am I? Is this the 30-degree angle right here? For the 60-degree angle, it's the 60. So it's not 60, though, because I have to change it to radians. Pi over 3, good. So pi over 3 is a good answer. If this is 1/3 of a pi, what is that? Well, I'm going to count it out. 1/3 of a pi, 2/3 of a pi, 3/3 of a pi, 4/3 of a pi, 5/3 of a pi. One answer, other answer. Okay? All right. Okay. I recommend that you check your answers on these. I did do number 24 and 25, I think, as practice problems in class. If you look back at your notes, at least I know we did number 25 together. So if you took good notes, you'll have that answer already. All right. And I encourage you to crank these out. We are going to grade some homework here in a few minutes, but for right now, you got some time to work on your homework.